Hey, this is Mr. J. Let's go through the trig ratios and solving note. First thing up, we've got this symbol right here. That symbol right there, a little O with a line through it, is pronounced theta. Okay? And it means an angle. So down here in this right triangle, I could put theta here, or I could put it theta there. There's actually also, there's several different Greek letters. There's theta, there's alpha, and there's beta. But we use primarily theta, okay? And so all it means is an angle, all right? Remember that angle A plus angle B is equal to 90 degrees, okay? They're complementary, all right? So we've got these three main trig functions that we need to learn about, and they are sine, cosine, and tangent. Each one is shortened like this right here. Sine goes into sin for sine, cos for cosine, and tan. All right. The sine ratio takes an angle in and returns a ratio. Okay. Same thing with cosine. It takes an angle in, and cosine returns a ratio. Tan returns a ratio. So the ratio returned by sine is the opposite side over the hypotenuse. Cosine is the adjacent over hypotenuse, and tan is opposite over adjacent. I can do the same thing for B as well. Sine of B, cosine of B, and tan of B. Okay, and what we do is we say that, okay, when we're going to look at sine of A or cosine of A or tan of A, we do what's called, we put a little swoosh here. We've seen that before in triangle congruency. Well, that means that that's our reference angle. It's the angle that we're going to reference. We're either going to be referencing A or B, but usually, not the same ones at the same time. Okay. So if my reference here is at A, then what I like to do is I always like to label the hypotenuse first, because the hypotenuse is the easiest to find. It's the longest side, sits opposite the right angle, and then I always like to identify the adjacent side, because the hypotenuse and the adjacent side will always form the angle that we're talking about, okay? And so that leaves this third one as the opposite. And sometimes I do that sometimes because sometimes when the triangle gets really narrow, sometimes it's a little bit hard to identify the opposite, okay? But we always can find the hypotenuse, and then the hypotenuse and the adjacent always form the angle, all right? So we've got that set up there. And so that's what that right there means, that the sine of A is going to be equal to the opposite over the hypotenuse in terms of these ratios. Okay, so let's come back here and let's actually put some letters. Well, let's put some letters here next. Okay, putting some letters. Just like it says up here, the letters for the angles are in uppercase, and the letters for the sides are in lowercase. So the side that's opposite A is pretty obvious there. The side that's opposite C is there, and the side that's opposite B is down here. Okay, and so we're going to go through here. We're going to see that these signs, A over C for sine, is also another way to express this here when you actually have lengths of sides. So think of A, C, and B, lowercase, as being lengths of sides, but we're just doing them as letters right now. So you can see that it's A over C. Then when we do cosine, it's the adjacent, which is B, over hypotenuse, which is C, so we've got that right there. And then when we do tan, it looks like tan is opposite over here and adjacent here, which goes to A over B. Okay, so you can either think of it as opposite over adjacent, or when we actually start plugging in numbers for A and B and C, you can think of it as numbers. Okay, well, when we come up here and we put our reference here on B, well, what we're going to see is that A, B, and C are still going to stay the same, but what we're going to see is this opposite over adjacent is going to change, because hypotenuse will always be hypotenuse, right? So now then, here's the adjacent side, right? And here's the opposite side. Well, if you notice that when we're down here at A, that changed, right? Here was the opposite, and right there was the adjacent. So you have to pay attention to this. When you switch from angle A to angle B, the opposite and adjacent are always going to flip. Okay, so sine of B is equal to opposite over hypotenuse. So sine of B is here. Opposite is B over hypotenuse C, B over C. Cosine B is the adjacent here, adjacent A over hypotenuse, which is C, so A over C. Tangent is opposite over adjacent, which is going to be B over A. Okay, so we got all that. Well, here's one thing that you really want to notice. You want to notice that no matter how many times you set this up and how many right triangles you deal with, you're going to see that, let's do this in red, you're going to see that sine of A, right there, sine of A is always going to be equal to cosine of B. Look at that. A over C, A over C. All right. It's always going to be equal to that right there. Doing this in green, we're going to see that cosine of A, B over C, is always going to be equal to sine of B. Okay, so we can write that down. We can say sine A is equal to cosine B. We can say cosine B is equal to sine of A. That will always be the case. It will always be the case in any right triangle. Okay? So what you come away with here is this association. Okay, you come away with this association. So let's come back here and let's just work with A. Okay, so let's keep it green. Let's work with A. Put that green there. Work with angle A here, like this right here. And so you have this association called SOHCAHTOA. S stands for sine, OH stands for opposite over hypotenuse, C stands for cosine, adjacent over hypotenuse, and tan, T stands for tan, which is opposite over adjacent. So you have this, what we call SOH, CAH, and then TOA. We write it like this right here sometimes so that we take these last two letters in each part of this association to actually create the O over H, A over H, and O over A. Okay? So now then, let's transition. All right, one more thing before I get rolling here. Notice that unlike sine of A being equal to cosine of B and cosine of A equal sine of B, that notice what happens with tangent. Tangent, the ratios will always be flipped. They will always be flipped. They'll be the reciprocals of each other. Okay? When we start putting numbers in here. All right, so let's do this. We've got a 3, 4, 5 special right triangle. So this side's going to be 3, that's going to be 4, and that's going to be 5. Okay? So now then, let's take this 3, 4, 5 special right triangle, and let's plug in the numbers here. So if we're at A, then that means sine is going to be 4 over 5, opposite over hypotenuse is going to be 4 over 5. Cosine of A is going to be adjacent over hypotenuse, so it's going to be 3 over 5, and tangent is going to be opposite over adjacent, which is 4 over 3. All right, well, based on what we just talked about, I can guarantee you that this ratio right here is going to be 3/5. Why? Because cosine of A is equal to sine of B always. I can guarantee you that this ratio right here, 4/5, is going to pop down here when we do it in just a second, because sine of A is always going to be equal to cosine of B. And I can take this 4/3 here and I can find the reciprocal of it, because we see that the tangent is going to be the reciprocal. So let's go through this. Now then, let's put our reference up here at B. So again, remember now that the opposite and adjacent have just swapped. Now then, let's look at this right here real quick. Let's get rid of these. All right. And we see that up here at B, let's start up with sine. So sine is going to be opposite over hypotenuse. Sure enough, 3/5. Now then, cosine is going to be adjacent over hypotenuse. Sure enough, there you go, 4/5. And finally, tangent is going to be opposite over adjacent, which is 3/4. So we've just proven what we just wrote just a moment ago, that the sine of A will always be equal to cosine of B, and the cosine of A will always be equal to sine of B. Might have wrote that wrong a moment ago and everything, I think, or maybe just in the wrong order. Okay, so we've done that here. Check that out. All right, so now then, let's come down here. Let's kind of get to the meat of the problems here. If we have this triangle like this right here, that we know at least one angle, that's one of the two complementary angles, and a side, then we can go figure out what the remaining sides are. Okay, so from this angle, let's go label our sides. So you have the hypotenuse, you have the adjacent, and you have opposite. Okay, well, the big thing here is you got to figure out, well, which trig function am I going to use? Well, Let's go after x first. If you're looking for a and you know the length of the hypotenuse, well, when you look at your SOHCAHTOA, you know a, you're looking for a and you know h, so you're going to use cosine. You're going to pass the angle 36 degrees into cosine, and you're going to set that equal to the ratio, which is going to be the adjacent, which is x, over the length of the hypotenuse, which is that right there. All right, here we go. One-step algebra to solve. Let's multiply both sides by 7, like that right there. And so that means that x is going to be equal to 7 times cosine 36. Now then, always remember this. Always put the known side out to the front of your trig function. Never put it behind, because if you put it behind like this right here, and you multiply and then you forget, it's going to be 36 degrees, and then you forget to close that parentheses that your calculator will probably automatically open up, you're going to be inadvertently multiplying the angle times that 7, which is very, very bad. So let's don't do that. Again, let's don't do that. So let's always put this side out front. Okay, if you go into your calculator and you multiply this out, you're going to see that x is going to be equal to 5.66 units. And always check to see if that makes sense, right? Always check to see if that makes sense. Yeah, definitely. If this right here is 7, then that certainly looks like that right there could be 5.66 units. Okay, so now that we've got x solved for, let's go solve for y. Okay, got to do the same thing. Got to decide which trig function we're going to use. All right, so let me just kind of erase this and reset it a little bit, and let's throw our, here's our angle, let's throw our adjacent, hypotenuse, and opposite. Okay, so in this case, we want to know what the opposite is, but we know the hypotenuse, so we look up here at association. We're looking for the O, and we know what H is, so it looks like we've got to use sine. All right, so let's set that up. Sine, same angle, 36 degrees, is equal to the opposite, which in this case is going to be the y, over, again, the known the known side, which is the hypotenuse, which is that. Same thing here. You've got the 7 in the bottom and everything, so you've got to multiply by 7, cancel there, multiply times 7, and so when we come over here and solve for y, we get y is equal to 7 times sine of 36, and if you plug that in the calculator, you're going to get, I believe, 4.11 units. And again, if that right there is 7, that right there is 5.66, then that certainly looks like the shortest side is going to be 4.11 units. Okay, well that's it. Thanks.